LiTRAS project is part of the European research program Clean Sky 2. It designs and develops an electromechanical actuator for the thrust reverser of short middle-range aircraft. The main innovation of the project comes from the use of linear electric motors instead of hydraulic systems or electric ones, but based on rotary motors, gearboxes and ball screws. 3 companies take part in this project: Braun, CESA, Héroux-Devtek and Tekniker, gathering this way a big experience in the design and development of electric motors and electromechanical actuators.
At the beginning of the project, we received the technical specification from Airbus. High push-pull force is the main requirement. This force is maximum when the aircraft needs to abort a takeoff in case of emergency. Additionally, the power supply is limited, as well as the available envelope for the integration of the LiTRAS. And also, high temperature and dirty environment contexts have been taken into account for the design of the actuator.
In the first stage, several motor principles were checked. That is, induction motors and reluctance principle, as well as several permanent magnet versions. As volume was very small and the power was limited, the permanent magnet motor was best choice. Due to the strong forces between lamination and slider, a sandwich design was chosen, which also gave the best force-to-volume ratio. The forces are still a problem because of the long slider and the bending.
LiTRAS actuator includes more components apart from the linear motor. The actuator is connected to the thrust reversal coils on one side, and on the other side it is provided with a rack and pinion mechanism for manual motion of the actuator during on-ground maintenance operation. Another device is the electromechanical hook to lock the actuator in position when the thrust reversal system is not operative. But one of the most challenging design tasks has been the design for manufacturing of the linear motor slider frame, a very slender part with very tight flatness requirement to ensure the motor air gap all along its active length.
After the design, a real-scale prototype is manufactured. Particularly delicate is the assembly of the different parts of the actuator, due to the huge magnetic attracting forces between the slider and the stators of the motor. To validate the prototype, an experimental test plan will be carried out in a test bench, applying the same forces that will be in the real aircraft.
The active volume, that is permanent magnets, lamination and the copper, did fit in the given volume in the specification. The parts around, that is the bearings, the hook and so on, are extra volume, which is critical. The maximum speed could be even higher to shorten the operation in emergency situations. More input power could give a smaller volume and smaller weight. The demands for the auxiliary system and the bearing arrangement needed more volume than expected. The inactive volume could be reduced in further design stages.
At the end, LiTRAS actuator provides a solution without fluid and with much less components compared to traditional rotary electromechanical equipment and hydraulics equipment. Improved safety and reliability, because this is a jamming-free actuator. Low maintainability, because it doesn't need relubrication. Environmentally more friendly, because it allows the reduction of dimension and weight of aircraft engines, thus leading to lower consumption and lower emissions.